All right, so just for our first video here, we're going to do a review of confidence intervals 6.1. So that's where we left off before we left school. We'll be doing an example, review the formulas. I'll show you some calculator tricks if you don't have a calculator. And then we're going to get into another formula for the minimum sample size, which is in your notes, but we haven't gone over yet. So first, let me show you this quick app that I found, or a widget, I think it's called. That is basically an inverse norm calculator. So if you look here, the address is up here. It's wolframalpha.com. It's one of its widgets. You can just search inverse norm online calculator. This is one of the first one that comes up. So let's say I want 5%. I want to find the inverse norm. I do probability of 0.05. Now you'll see it's not the fastest, but at least on my internet, but it does work. Remember, it's a plus or minus value. You want to use this right tail positive value. So for 5%, 1.645. So if you need that inverse norm or normal CDF, you can Google just inverse norm or normal CDF calculator. There's lots that come up. Find one that's easy to use like this and go ahead and use it. So the first problem that we're actually going to go over is problem number 36 on page 306. Like I said, just as a quick review, I know it's been a while since we've done some math. So if we look at number 36, right, some things that we need to identify, right? When we're going through this, we need to identify our sample size, our mean, and our standard deviation. And we have to make sure that our sample size is above 30, unless they give us the population standard deviation, then we're okay. So you'll remember, here are the formulas. So margin of error, remember it's the z-score from the confidence that we have in our notes for most of the more popular values. The population standard deviation, unless n is greater than or equal to 30, then we can change that out for s. So remember, this is interchangeable with s if n is greater than or equal to 30. And then we take that margin of error, add or subtract it to our x bar, and we get an interval, which is going to look like this. So the first things I need to pull out of the problem are these, right? So if you look at number 36, it says sample of 36. It says our confidence levels up here in the directions, they want us to use 90 and 95%. I'll show you 90 for now. So 90%. And our population standard deviation is 10.27. And our sample mean, they gave us 116.16. Right, so that's what I'm working with. I'll be using these formulas. So if you go to your notes, you should have a z-score for 90%. 90% should be that 1.645 value. Right, that's our ZC for 90%. Then we'll just put it into the formula. Our margin of error is going to be equal to that 1.645 times the standard deviation, 10.27 over the square root of n, so over 6 over the square root of 36. All right, so that's how we start off. Then we're going to plug that into our calculator. So I'm going to use my 89 here. Except for this, you can just use your phone calculator if you'd have to. 1.645 times 10.27 divided by the square root of 36, which gives me something like 2.82 if I round to the hundredths position. So 2.82 is my margin of error. To make the actual interval, I take my x bar and I add and subtract 2.82. So if I take 116.16 minus 2.82 and 116.16 plus 2.82, that creates my interval. Should give me something like 113.34 to 118.98. Remember, we're putting mu in the center, so it's mu is greater than 113.34 or less, right, and less than 118.98. So that's my interval, margin of error, interval, confidence level. That's what we went over before you left. Now, in your notes, there's another formula. So let's pull up your notes here. I'm going to get rid of this for a second and pull up your notes. Let me share my original screen with you. That's not what I wanted to do. Yes, it is. All right. So if we look at the notes, this is the stuff that we went through the other day. I'm just going to go through this to get to where I want to be. All right, so here we have, if you're trying to find a sample size, right? If you're given a confidence level and the margin of error, you can find the minimum sample size needed to estimate the mean. So if you're estimating sample size, remember a lot of times sample size are the number of people, number of objects, right? They're going to be whole number objects. So something to keep in mind with this will always be rounded up to the next whole number, right? No matter the decimal, always round up to the next whole number. So make yourself a note. So we have the ZC, the Z-score coming from our confidence value times the standard deviation divided by the margin of error, and then all of that squared. And the margin of error is something you might want to write down as well. Margin of error, a lot of times in the problem, it will say within. If it's within 0.5 or within 2, right, that is your margin of error in the problem, right? If sigma is unknown, you can estimate it using the sample standard deviation. Once again, as long as you have a preliminary sample with at least 30 members. So if you wanted to do this problem, it says estimate the mean number of sentences in a magazine. How many magazine advertisements must be included? You want a 95% confidence sample mean within one sentence, so margin of error is within 1. And you're assuming the standard deviation is about 5. So we say, well, 95%, this is in your notes, but I'll show you again. 5% left over, 2.5 on each side. Inverse norm of 2.5% is 1.96. Plus or minus, we'll use the positive for the Z-score. My standard deviation was 5. My margin of error was 1. That was that within value. And if I plug it in, I get 96.04. We can't have 0.04 for our sample size, so we always round up to the next whole number. So at least 97 magazines. Right, here's another one. If we have 99% confidence within 2 units, right, within 2 units, same idea, we would do the 2.576 for our Z-score, margin of error of 2, put it in with the same standard deviation, and we would calculate that value as well, right, assuming it's normally distributed. So that is that. They're just formulas. They're in your notes. Plug them in, use them. Within is your margin of error. Not too bad. I do have some problems that I would like you to try, which I'll share in Classroom. Just make sure you like this video, subscribe, and keep up to date on all the videos that are coming. Lots more in the near future. So with that, let's go do some problems, and I'll see you next time.